Hey guys, welcome back to Crypto Pumps. As you probably know by now, Michael Sutton, which is one of the developers for Kaspa, released a post late or yesterday saying later tonight that there was going to be some news, and then he did, and it turned out to be about the hard fork to 10 blocks per second. So it was like 11 o'clock, 11 p.m. my time by the time he released it. I was listening to blockchain banter and I was half asleep on the couch. So this is the first time I've got a chance to talk about it. So in case you haven't seen it yet, this is his release. And if we go into detail about it, Michael has written here that with the successful deployment of Rusty Kaspa node software, stable release, and its broad adoption by the Kaspa P2P network and mining community, 97% of Kaspa blocks are mined via uh, Rusty nodes, Rusty Kaspa nodes. The core open source development team is now starting to prepare for a hard fork that will, among other things, increase the block rate of network from 1 to 10 blocks per second. In this post, I outline a tentative roadmap for the upcoming hard fork, hereby named Crescendo. What it will be likely include in the process deploying it. So remember that we're only at 90% Rusty Kaspa nodes. Some of them are still on Go, but as Shoy said before, we don't have to be at 100% Rusty to do the hard fork to 10 blocks per second. And that's what they're doing, because seemingly the few of them that are staying on Go are it's backward compatible. Like it'll still work for a little while. But this is the roadmap here. So they have it released there, but just you can go into a bit more detail here. So it has at a high level, here's how we envision the steps needed to implement such as acceleration on Caspa's main network. The process involves the following iterative phases: launch and stabilize, launch testnet, and it says the existing 10 blocks per second Kaspa testnet, which has been in operation since January 2024. So that's been running on testnet 11 in the background the whole time. Identify bottlenecks, um, identify processing bottlenecks, and make performance optimizations to lower the hardware specifications required for node running. That's done. Iterative, I never heard of that word before. Iterative improvement, repeat the above until the minimal specs are affordable enough and low enough to satisfy the decentralization required for the mainnet. We are here getting close to the convergence of this optimization loop. Approximate timeline is 2 months from now. Enhanced user experience. This has 3 months from now. I was doing these wrong. I was adding these up last night. Last night I was going 2 months plus 3 months, but no, it's from now. So this one's 3 months from now. Additional features, implement any additional hard fork features and deploy them on testnet 11. Target timeline 4 to 5 months from now. Some features might be excluded to fit the timeline. Feature freeze, hard fork version, implement the hard fork transitioning version, deploy transition testnet, deploy the transition version testnet 10, 1 blocks per second testnet to simulate the mainnet transition, and mainnet deployment where hard fork transitioning activated 1 to 2 months later. So in my head, I have 4 to 5 months from now, and then he has this will take 1 to 2 months after that. So I think that's 6 to 7 months is what I think. So if we have a look at this, so we're on August, we have 1, 2, 3, 4, 5, 6, 7. So I'm guessing around February or March if they're trying to stick to the roadmap. So February or March, that's early next year. So it's great for the Castle community. So that is something to look forward to. Um, and somebody here asked the question, quick question to the people of the CAS community. There's a hard fork being proposed that increases blocks per second from 1 to 10. How does this affect the issuance schedule of new Kaspa? Kaspador answered it here. Nothing changes in terms of mining of the remaining of the supply. When 10 blocks per second will be live, the reward will be current rewards divided by 10. So let's say a block reward currently is 50 CAS. It will be 5 CAS for each block. But then there's going to be 10 blocks more as well, or sorry, is it nine blocks more per second? And the transactions within the block stays the same. And with KRC20 coming out soon, be good for miners. And then this is a visualizer just to show you. This was this guy here at CryptoZ. He put this visualizer out in case you haven't seen it. So the bottom one is Kaspa running at 10 blocks per second, and the top one is Bitcoin. So you can see the difference in speed. At the moment, we're on 1 block per second, and that's 600 times faster than Bitcoin. But when they do the hard fork to 10 blocks per second, it'll be 6,000 times faster than Bitcoin. And that's that one. And anybody, I've seen a couple of questions. Anybody holding Kaspa in a wallet or in your Tangent like me, or if you're holding it anywhere, you don't have to do anything. It's only, and miners don't have to do anything either. It's only if you're running on a node that I think you have to get it switched over to. Well, no, you don't even have to get switched over. If you're running a node, there's going to be an update for the hard fork that'll switch it over to 10 blocks per second. That's all I know about that. So that's super bullish. 10 blocks per second is one of the big things that Jonathan said he was focusing on first before he got to smart contracts. The other thing was Dagnoi. So you probably heard of Dagnoi protocol. This is it's maybe a little bit complicated. It's to do with network latency. I think other cryptos, they have to leave 18 seconds buffer for network latency because like in some places internet is slower and it might be down. So they need latency. But this video, this is Wolfie, and he kind of explains it. It makes it a bit simple. So just try and have a listen to this because it's a serious upgrade for Kaspa. It's gonna be coming as well.
Michael Sutton came up with this concept of a parameterless protocol. It's very complicated from what I understand. So in my cat brain, how I picture it is like right now, like Bitcoin and all the coins, even Kaspa right now, they have this assumed, this just in case waiting time, like a timeout. We gotta hang out for a couple minutes or at least several seconds. Like even for Kaspa right now, it's 18 seconds. So that's what all the projects in the whole world have right now, this just in case thing. Just in case there's some internet problem or some weird thing that's making them not find out about the next blocks that just came out, we're just gonna wait, this long time, just in case, right? So Michael Sutton had this idea. What if we didn't wait just in case? What if we assumed that there is no problem and everybody hears about it right away? And then we build a sensing mechanism where we monitor the network and we look for delays. And then if we begin to sense delays in some problem like internet or some problem somewhere in some part of the world, then we start to scale in a little bit of a wait. And then if the problem gets worse, we can put a little bit more temporary waiting time. And then when the problem goes away, we remove the waiting time again. So that's what Dagnite is. And nobody else ever thought anything like this. To give you an idea how complicated it is. Okay, he thought of the idea 3 years ago, and it was said to be like in the research papers in the world of computer science, what they call an impossibility. Like they said it's impossible, okay? So all the smartest people in the world that thought about it said it's impossible to do this. But he thought maybe it's not impossible. And then they got almost all the way there. Thought about it, wrote down, formulas and stuff on paper for 2.5 years thinking about how they can do it. They got almost the whole thing together. There was one piece of the puzzle missing. And he went over it and over and over it, and he almost had he had to pause. He was thinking, I'm spending more and more time on this, and it may actually be an impossibility. Maybe they were right. So he had to stop and then focus on something else, which happened to be Rust programming language for a couple months. And then all of a sudden, one day, out of the universe, the answer came. And they got it. And they proved it on paper that it's possible. So in a nutshell, they say they're confident that it's pretty much the largest breakthrough advance in distributed computing and distributed systems since 2008 when Bitcoin came out.
So there you have it. Dagnite is like all these, the hard fork and Dagnite, they're all super impressive. And Dagnite is probably going to be next after the hard fork. That's everything. Just on the only thing on KRC20 is Nacho. He has up in the Discord the Nacho token minting progress bar on our website is now pulling live data from the Casplex API again. Based on currently available data, it seems Nacho still has more than 90% of the supply to be minted. So less than 10% of Nacho supply looks to be distributed across 6,051 holders. Now, that is what decentralized and fair launch looks like. I'm so excited to see how this plays out when we hit 100% minted. And yeah, you can see holders. So that is, there's only 10% and it's spread between 6,051 wallets. So that's pretty cool. So yeah, there's still, when minting happens, there's still plenty of Nacho to go around, 90%. If you're interested in Nacho, I'm going to be getting that one myself. And Nacho, this card, I had an entry in for this. Nacho had a competition to design a Tangem card, so this is the one that won. So they are going to get Tangem to create this, and hopefully soon Tangem will come out and say they are ready to hold KRC20 tokens. Hopefully before it launches again. And that's the end of the video. If you found it helpful, please leave me a like, and I will talk to you again. Thanks for watching.